Good morning. So today we will talk about the Bohr model and the quantum mechanical model of the atom. So our objectives are the following. First, demonstrate an understanding of the development of atomic models that describe the behavior of electrons within atoms. Second is you can be able to describe the Bohr's model as a refinement of Rutherford's model. And the last objective, number 3, describe the main features of the quantum mechanical model of the atom. So, the study of atoms can be traced back to Democritus in Greece, where a philosopher who actually started the idea that all matter can be made up of particles, indivisible particles, which he called atoms. So that is where and when atoms are born. The idea of atoms are born. So in 1803, John Dalton proposed the first model of the atom, which he called as the solid sphere model, or others called it as a billiard ball model. And because of the experiments conducted that have led also to the discovery of the different parts of an atom. So it has been discovered during the time of Thomson that atom composes of subatomic particles, and one of the first subatomic particles that was discovered is electron, that have led J.J. Thomson to propose the model called plum pudding model of the atom. And in 1911, a new model was proposed, and a continuing study of the development of the atom, which is now transitioned from plum pudding to nuclear model proposed by Ernest Rutherford. So during this time, nucleus was discovered. So that is why the model is called nuclear model. So if you're going to trace the development of atomic models, starting from a solid sphere to a model that composes of its subatomic particles. So from billiard ball model to plum pudding model to nuclear model. Now the question is, what is the widely accepted known model as of today? Is it Ernest Rutherford? What do you think? Okay, the answer would be no, because Ernest Rutherford's model has also its drawbacks. It was theoretically inappropriate, but of course his idea lays the foundation also of further discoveries and the development of the atoms. He mentioned that yes, electrons actually revolves around the positive charge, which is the nucleus, compared to J.J. Thomson, where he described the atom as a positive ball of electricity. Embedded onto it are the negative charges called electrons. But that was not approved by Ernest Rutherford, because he believed that it has a nucleus at the center, and revolving around the nucleus are electrons that move at a very high speed and looks like an empty space. The atom looks like an empty space. So now, another scientist have proposed a model and refined the idea of Ernest Rutherford, which is actually who is his actually student during that time. So what was the problem of the model of Ernest Rutherford? So it was actually a breakthrough in his study. It was a breakthrough in his study, but the problem is that if electrons move, right, then it moves very fast. If an object that revolves in a circular motion would gain an acceleration, and if it applies to the atom, that means it will liberate some form of energy that it will end up falling into the nucleus. So if electrons fall into the nucleus, it will cause for the atoms to collapse. It will collapse. But does not always happen in all atoms, because by nature atoms are stable. Okay? So all atoms are stable. Now, Niels Bohr, a student of Ernest Rutherford, have refined the model of Ernest Rutherford. So these are the assumptions of Niels Bohr. He proposed that only certain special orbits, which he called discrete orbits of electrons, are allowed inside the atom. Second, while revolving in these discrete orbits, the electrons do not radiate energy. So these are the major predictions of Niels Bohr of the atom. So now you will observe that the model of Niels Bohr has specific orbits. Unlike in Ernest Rutherford's model, it just, Ernest Rutherford did not describe how electrons move around the nucleus. But this time, Niels Bohr have mentioned orbits that where electrons are allowed and can be found. And these orbits where electrons occupy do not radiate energy. So it was in 1913 that he added the concept of orbits. And when you say orbits, these are stable, discrete regions where electrons do not experience spontaneous energy absorption and emission. And these orbits are also known as energy levels, wherein the energy level, it denotes a certain distance from the nucleus. So, very simple, in a simple understanding, Bohr suggested that electrons move around the nucleus in a certain circular orbits. So, now we have the so-called ground state and excited state. What do you mean by this? Ground state means is the lowest possible energy level an electron can be located at. And when you say excited state, is the energy level higher than the ground state. It is where the electrons move from lower energy level to a higher energy level at a very quickly, and it will go back to ground state. So this is now the model of Niels Bohr. You will observe that he actually have defined the location of the electrons. He accepted the idea that nucleus are found at the center, but this time electrons are actually found in circular orbits, which he called energy level. So you will observe, so these are orbits which are also called energy level, which can be represented by a number. So the orbit closest to the nucleus is represented by number 1, n, which is the energy level equal to 1. The second orbit closest to the nucleus is energy level 2, followed by 3, 4, 5, and 6. So that's how Bohr described the orbits. So now, because Ernest Rutherford cannot explain this, that it's very problematic because the idea of Ernest Rutherford would end up collapsing the atom. So we have now the idea of Niels Bohr that explain that yes, atoms are stable by proposing his idea. So that is his postulates. Okay, so imagine that it can be described like a solar system based on the idea of Ernest Rutherford. And then now the atomic structure looks like this in Niels Bohr. It has a nucleus, and the electrons occupy a certain regions called orbits, which called energy level, which he also called shell. It's also called shell. So that energy level is where electrons are found that do not radiate energy. So each shell has got a defined energy level. So the names of the shell, according to Niels Bohr, it can be named as the closest to the orbit is K shell, L shell, M shell, and N shell. So K, the nearest to the nucleus. But that energy shell is also called energy level. Do not be confused of that. So it's called energy shell, it's also called energy level, which can be represented by numbers which we've mentioned a while ago. Okay, so now, because of the idea that it does not radiate energy, okay, because atoms are by nature stable. And according to Bohr, Niels Bohr, that electrons would only emit photons, or what we call light, when moving from a higher orbit to a lower orbit. So, Bohr's model introduces now the concept of quantized energy levels, wherein each orbit has a definite amount of energy. So orbit 1 has a definite amount of energy, energy level 2, and so on and so forth. And the released energy in this level is equivalent to a specific wavelength of light, which can be observed as the atom's resulting spectrum. So, what do you mean by this? So according to Niels Bohr, electrons would only emit photons, or what we call the light bundles, when it moves from a higher orbit to a lower orbit. So let's imagine that these letter E are the electrons surrounding the nucleus, and we have the 2 electrons in energy level 1, and there are 8 electrons in energy level 2. There is an increasing energy of orbits. Now let us say that this electron, or the outermost energy level, this one, from energy level 3, will move from energy level 3 to energy level 2. When that happens, a photon with energy is released. So again, when you say photons, these are bundles of light energy that is emitted by electrons as they go from higher energy level to lower levels. So this is the result where when a hydrogen is actually placed in a condition where it will release actually its energy, so it will result to this kind of colors, it will result to this spectrum. So now, what's the problem with Bohr's model? Okay, according to during his time, that Bohr cannot explain why electrons would not emit photons all the time, because he said that it does not radiate energy. It would only emit photons or radiate energy if electrons move from a higher orbit to a lower orbit. So now, one of the fallbacks of Bohr's model is that he was able to explain the atom of hydrogen but failed to explain larger atoms. So that was the major fallback of Bohr's model. That he could also explain why electrons would not emit photons all the time and why special orbit exists. But the question is, during his time, was Bohr right? The answer is yes. But the problem is nobody knew Bohr was right during that time. That's why scientists keep on finding answers and led to the development of many discoveries of the atom. So, because of scientists looking for answers, now Louis de Broglie, who is a French scientist, he said that if a particle has a momentum and it has a wavelength, then the electron can be probably exist as a wave. So, this gives birth to a new model called quantum mechanical model of the atom. So, Louis de Broglie developed the wave-particle duality. That means electrons, if it behaves a particle, it also behaves like a wave, which was also very controversial during that time, because if we believe that electrons behave like a wave, that everything that we feel, that we touch, all matter that's considered as matter, that means its particles moves like a wave. But according to Louis, that because atoms are very small, that we cannot really be able to really determine of that motions of electrons, because we cannot see it by our naked eye. So according to his theory, subatomic particles like electrons can also behave like a wave rather than particles with determinate positions. So electrons motion around atoms shown as de Broglie. So instead of, like certain dots in the orbit, like in Niels Bohr's model, he describes the motion of electron as moving like a wave. Now, the question now is, what is the nature of these waves and how and why do they exist? So now, this is a very crucial questions that has been answered by Erwin Schrödinger. So Erwin Schrödinger said that if it is a wave, that it can exist anywhere in a three-dimensional space. And he's very popular of his Schrödinger equation that explains the hydrogen atom with more details and precision than Bohr's model. And he was able to successfully explain larger atoms or more elements in the periodic table than Niels Bohr, because Niels Bohr was only able to explain the hydrogen atom but failed to explain larger atoms. But this time, with the discovery of Erwin Schrödinger's effort and his Schrödinger's formula or equation, he was able to explain larger atoms or elements in the periodic table. So now it led to a new model that has been widely accepted today, which is called the quantum mechanical model of the atom. So the model also indicates the exact position of an electron cannot be precisely determined. So the uncertainty principle states that we cannot exactly locate the position of the electrons because of its great momentum. So it also denies the probability of having electrons in definite orbits as stated in Bohr's model. Now, the word orbitals is used in quantum mechanical model of the atom. So orbitals are regions where where electrons can be mostly found. So in Niels Bohr, it's called orbits, where it can be found. But in quantum mechanical model of the atom, it is called orbitals, the regions where we can most likely found electrons. So these orbitals are explained mathematically in an equation popularly known as Schrödinger equation. So electrons in an atom are described by solution to the Schrödinger equation called wave functions, which we will explain further on how on the next lesson how Schrödinger's describe the hydrogen atom using quantum numbers. So from a model that looks like a solar system to a planetary model, now we have a model called the quantum mechanical model of the atom. So you cannot see there like a specific orbit, but you have the so-called orbitals where regions where it's highly concentrated is where you can mostly find electrons. So that means an atom is not empty space, but it is filled with cloud of electrons, an electron cloud. So which can also look like that. Okay, so in Werner's Heisenberg's uncertainty principle that you cannot locate the exact position of electrons in the atom because of its great momentum and speed. That is why the quantum mechanical model of the atom explains that instead of specific orbit, there is just a probability called orbital or a region where you can most likely find an electron, but not specifically that yes, you can find there an electron in a specific orbit like what Niels Bohr has mentioned. So now I want you to answer these questions. Write true if the statement is true. If not, then write it false, which we will answer in our synchronous discussion. So the first question is, in Bohr's model, electrons move about the positive nucleus in discrete energy levels. True or false? Number 2, in Bohr's model, electrons emit energy as it falls to the positive nucleus. Is it true or false? In the quantum mechanical model of the atom, electrons move about in fixed orbits. Number 4, in the quantum mechanical model of the atom, electrons move about a fixed positive nucleus. Number 5, in the quantum mechanical model of the atom, the exact position and momentum of an electron can be determined at the same time. Is it true or false? Let me know your answers in our synchronous discussion next meeting. So thank you for listening and see you next meeting.